8.3 is similar polygons. Okay. With similar polygons, the first thing we need to be aware of is what is a polygon. Okay, we've talked about this in the past. Anybody give me one characteristic of a polygon? Carly? No curved edges. Carson? It has to connect. What was the last one? There was 3. Right, none of them can cross. Okay, so you have no curved edges, no crossing lines, and everything has to connect, correct? Okay, on your test, you had one that looked like this. Was that a polygon? No, because this side doesn't connect at the other end, does it? Okay. Okay, so that would not have been a polygon. Let's go ahead and define similar polygons real quick. Okay. Similar polygons are polygons with proportional sides. Okay, not only are the sides proportional, but each side, okay, it's not just 2 sides, it's all sides. So each side has to have the exact same ratio when you're talking about corresponding, polygons with corresponding proportional sides. Okay, so if you're talking about the left side of a rectangle, then the left side of the other rectangle, that ratio has to be proportional to the tops. Okay, we'll get to this in a second. Okay, now, the diagram that they have there, I'm not going to use. I'm just going to use a triangle for us. Or 2 triangles, I guess. Okay, so let's go ahead and say, let's just say the right triangles for our ease. First thing we need to know is that in similar figures, all of your corresponding angles are congruent to each other. So notice A is congruent to D, corresponding, right? B to E, corresponding, and C to F, because those are corresponding angles. Okay. Now there's a few new types of things that we need to learn here. The first one is just the similarity statement. You guys remember when we did congruent figures, how we had our congruence statement? Okay, we also have a similarity statement stating that triangle ABC is similar, there's a new sign for you, is similar to triangle DEF. Does it matter what order I put my letters in? Yes. Now, it doesn't matter if I started at a different point here, I would have to start at the same point here, right? So it doesn't matter what point I start at, as long as I start at the same point on both figures and go the same direction. Okay, so your corresponding angles have to line up here, just like in congruent figures. What was that called? Similarity statement. That's our similarity statement. Okay, the next thing that we need to talk about is what's called your statement of proportionality. That's just stating what is proportional. Okay, well, AB corresponds to what? DE. Okay, so that ratio has to be equal to BC over EF, which has to be equal to AC over DF. Okay, so all we're doing is we're writing down our ratios and we're setting them all equal to each other. Isn't that what a proportion is? Is ratios set equal to each other? Okay, so you're just setting your corresponding sides up in a ratio and you're setting them all equal to each other, because if the shapes or figures are similar, then your ratios of sides have to be proportional. Okay, this is called a similarity statement. This is called a statement of proportionality. Okay, and I'm not going to ask you to tell me what this is called very often, but the book is going to ask you to write the statement of proportionality. Okay, so you're going to have to understand that they're asking for this. Okay? Questions so far? We're still working with proportions, aren't we? Okay, so that's not changing. Now the next thing we have I'm just going to keep doing triangles because they're for the sake of time mostly. Okay. Let's say one side is 15 and this one's 10, 12, and 8, and 9, and 6. Okay, so I have A, B, C, D, E, F. And then they go ahead and they give me this information. And your angles are always going to be congruent in similar figures, your corresponding angles. They want to know, are those two shapes similar to each other? Okay. Well, step one is just having the angles congruent, right? Okay, looking at that, they're probably going to be similar. Okay, now, right now, we also need to figure out, is the statement of proportionality true? Okay, do my ratios line up and are they all equal to each other? Okay, so we need to go through and check that. So let's check our corresponding sides. 8 corresponds with what? 12, because there's one tick mark in 3, 1 and 3. Okay, so 8 over 12, and that reduces to what when I take a 4 out? 2 over 3. Okay, so AB over DF is 2 over 3. BC corresponds with what? FE, so I have 6 over 9, which reduces to 2 over 3. And then 10 corresponds with 15, which reduces to 2 over 3. So, are all my sides proportional? So, are these two shapes similar to each other? Yes. Since they're similar, Taylor Hart, can you give me a similarity statement? Triangle ABC is similar to triangle, careful, DFE. I didn't write that in order that time. Okay. That's a pretty common question that you're going to face. Are they similar? If so, write the similarity statement. Okay. Can we handle that so far? Okay. After that, things don't get too much more difficult. Okay, that's kind of the basis of today's lesson. Now, taking a look at example 3, we're not going to go through that whole thing. Okay, we're not going to work it on the board anyways. It says, you've been asked to create a poster to advertise a field trip to see the Liberty Bell. You have a 3.5 inch by 5 inch photo that you want to enlarge. You want to enlarge it to be 16 inches wide. How long will it be? What are you doing there? How are you going to solve that? You're just going to set up a proportion, right? Okay, you have a 3.5 by 5 and a 16 by X. Okay, Taylor Arnett, what's one proportion you can set up for that? Okay, 3.5 over 16 and 5 over X. Are there other options? Yeah, the book itself gives you a different option. Okay, there's actually probably about 8 options when it's all said and done. Okay, so again, don't think that you're setting it up wrong if it's different than somebody else's. Okay, you're fine. Just make sure that everything you're setting up in a ratio has what? Something in common. Okay, make sure it has something in common. If there's no relationship, then they can't go together. Okay, the next thing we need to talk about is a scale factor. And you've been working with scale factors. You just haven't known it. We haven't used that word. Your scale factor is the ratio of the lengths of two corresponding sides. The ratio of the lengths of two corresponding sides. So knowing that, what is the scale factor of this triangle to that triangle? 2 to 3. Okay, your scale factor is 2 to 3 because that's your ratio of one side to another. And they're similar shapes. Okay, they have to be similar shapes to have that scale factor. Okay, so the example they give you in your book is they give you a pool with a patio around it. And the pool is 32 feet by 16 feet. And then the patio is 48 feet by 24 feet. The question the book asks is they want us to calculate the scale factor of the patio, of the patio to the pool. So if we're doing patio to pool, what has to go on top? The patio length, right? Is it going to be easier to reduce 48 and 32 or 24 and 16? Probably 24 and 16. Is it going to matter? Not if they're similar. Okay, it's not going to matter. I would choose 24 and 16. So I'm going to do 24 over 16. What can I take out of both of those? An 8, and I get 3 over 2, which is now my scale factor, right? Okay, so there's your scale factor right there. Okay, you just found the ratio of two corresponding sides of similar figures. Now the next question wants to know, what is the ratio of their perimeters? So what do I need to do to find that? Find your perimeter, right? Okay, so 48 and 48 is What's 48 plus 48? 96 plus 24. 120 plus 24. 144. So I have 144 feet for the perimeter of my patio. The pool, 32 plus 32 is 64 plus 16 is 80 plus another 16 is 96. So I have 96 feet there. And there's my ratio, right? But I need to do what? Reduce. What do we want to take out? A 12. So I get 12 over 8, which reduces to 3 over 2. What do you notice about those two things? They're the same thing. So if we could come up with a way to be able to say that the ratio of the perimeters is the same as the scale factor, that would save us a lot of time, right? I'll bet you there's a theorem and it comes right next. Okay? So that's what we got next. Our theorem, it doesn't have a name. I went ahead and gave it one that we could recognize. Polygon. Actually, I called it perimeters of polygons. I do.
Thank you.
Okay, perimeters of polygons. And I'm not going to put the diagram down, and I'm not going to put all the other stuff down. Okay, but I'm just going to put the words. It says, if two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Also known as your scale factor. Everybody have that down? Now, I'm not going to do another example with that because the example that we really needed was this previous one. Okay, right there, I proved that that works, right? Okay, and that'll work every single time. If you can find your scale factor, then you already know the ratio of your perimeters. Okay, so just be aware of that. The last example I want to do, a lot of you are probably going to think is pretty easy. Okay, I'm not going to go through and write everything down here, but they tell me the figures are similar. Okay, they tell me that. How do I figure out what Z is, Ryan? Z over what? So Z over 10 is 6 over 15. Are there other ways to set that up? Yeah, that's not how I'd have done 10 over 15 and Z over 6. Is that okay? Sure, that's fine. Okay, there's multiple ways to set this up. Now, this only works if the figures are similar, correct? Okay, if the if the figures are not similar, you can't set up a proportion to solve unless you know more information. Okay, so don't just start assuming information just because you have two shapes. You have to make sure they're similar first. Now, back to a couple things we talked about yesterday. First of all, can I reduce vertically this fraction? Yes, I can. So I have Z over 10 equals 2 over 5, right? Can I reduce diagonally or cross-reduce? Why? There's an equal sign. This is a proportion. You cannot cross-reduce a proportion. Could I cross-reduce if it was just multiplication? Yes, but not with an equal sign, not a proportion. Hey, you can reduce vertically, but not cross-reduce. Okay, so then I just need to do what to solve this? Cross-multiply, I get 5Z equals 20, Z equals 4. Okay, again, I knew that problem was going to be a big challenge for us. Okay, but we need to make sure we can know how and when we can reduce things. You guys have any questions about that? Not a lot different from what we've been doing, right? Okay, be careful when you're naming similar figures and stuff like that. Okay, be very careful with that. For tomorrow, I need you guys to do this for me. Now, there's a couple problems. I can think of one in particular where you have to do one of the odds to be able to do the even. I think it's like number 21. I think you have to do 21 to be able to do number 22. Okay, so just keep that in mind. If you get to something and you're like, well, I can't do that because I don't know what X, Y, and Z are. Oops, that was probably loud on the video. Because I don't know what X, Y, and Z are. Okay, well, you probably need to find them, right? Okay, so be aware of that.